Hello everyone, welcome back to the YouTube channel of Developers and Coders Club. Today we are here to discuss the problem sequence master which came in recent contest of Codeforces round at 58. So in the problem, this is given that there will be an array that will be good only if there is a condition that size of that array is 2. Then if we select any subsequence, if we select any subsequence of size m, then product of arm elements of this subsequence is equal to sum of the arm elements that are not in this subsequence. What does this mean? That like say that this is the sequence of size 2 into m. Then we select randomly some elements and that is the subsequence of size m. So what is that? Like call it A, B, C, then this is X, this is Y, this is Z. Then this condition says that a multiplied with b multiplied with c should equal to x x plus y plus z. That means for a given array of size 2 into m, for every subsequence of q and length of that will be m, the product of m elements in that subsequence will be equal to sum of m elements that are not part of that subsequence. And that is the mathematical equation for that. So there is one another term that is distance. So distance between two arrays will be sum of from I equal to 1 to k of ai minus bi. This means that if there is array A and there is a array B, so uh, absolute difference of this and this, absolute difference of this and this, absolute difference of this and this, and sum of these all, that will be distance between these two arrays. Okay, so then what we need to find the minimum distance between P and Q. What is P? That you are given positive integer n and array P of two integers. There P will be given to us. And what is Q? That Q is all good arrays Q of length 1. Length Q will be the all good arrays which we can form and length of that will be 2n. And there is a condition for that, that it should be a good array, and this is the condition. So P will be given to us, this type of P will be given to us, and we need to form Q, and we need to print the distance between these P and Q, and their distance should be minimum as much as possible. So if you think for like 1, 6 and 9, then if we like given to us that 6 and 6, so for this value of n is 1, and this is size of 2 into 1, that is 2. So if you select any subsequence of this of length 1, like there will be only one 6, then multi product of this is 6 and sum of remaining element is also 6, so that is equal to that. So q is a good array. So for 6 and 9 and 6 and 6, absolute difference 0, absolute difference 3, 0 plus 3, that is 3. So this is the 3. Then if we talk for 1 2 2 1, so a good array can be of size 2 into 2, that is 4. So that can be a 2, 2, 2, 2. Given to us that is 1, 2, 2, 1. Absolute difference 1, 0, 0, 1. And sum of this, that is 2. So 2 is written here. And for these 5 and 13. But how we got these 5 and 13? That is the main point of discussion. If you anyhow, if you get the good array for this and for this, then just think you have solved 80% of question. If you have found the good array for this case and for this case, that is the most uh, yeah, hard part for of this question. So there is a line written here that it can be shown that for all positive integers n, there will be at least one good array exists. So first of all, I didn't get that how can be it possible. Like what I get that a 2, 2, 2, 2. This is the one of the good array which I got randomly. Like I don't need to think so much for this. So that is I got randomly. Then other than it, I got that any good array that is only consisting of only zeros, that will be also a good array. This is also a good array, and this is also a good array. But size of this should be only 4, because if we see in this 2 2 2, then you can select any subsequence of size 2, that will be 2 and 2. Remaining will be also 2 and 2. Then multiple of 2 into 2, that will be equal to 2 plus 2. So that is satisfying. So this is also a good array. And this is also always will be satisfied, because multiple of these will be 0 and summation of these also will be 0. So till now we only have these two types of good arrays. That is, one is that size of 4, and another one is consisting of only zeros. What I get that if you see this test case, that is minus 2 minus 2 2 2 minus 2 minus 2 2 2. So if we concern for this, that is 2 2 2 2. Then if we get the absolute difference, that is 4, that is 4, that is 0, that is 0. Summation is 8, but here we are getting 5. So this cannot be answer for this. Then if we talk for zeros, then also we get like absolute difference 2, 2, 2, 2. And summation here, that is also 8. So that also cannot be. So what I got here, that there also exists some another good array of size 4, which I am not able to find out yet. So now my target is that find a good array of size 4. That is, if we take P, take Q, that good array, and P this one, then we get answer 5, because we are getting that here. If P is this, and we get any good array of size 4 Q, then that should answer give us a 5. So now my target is find a good array other than these two. So I also spent almost 30 to 40 minutes on this, but I didn't get. So what I did, that I take some type of these condition, that I take like you can think, but maybe you didn't get, like I also didn't get. So what I did, like I make some randomization, make a vector of minus 2 minus 1 0 1 2, then a b c d, that is randomly integers from these vector. So now what our target is, that just think that our good array is a b c and d. Now what is our target, that for every subsequence of size 2 of this array should follow the condition that product of that subsequence should equal to summation of the remaining elements. What I want to say, that if we select A and B as our subsequence, then A multiplied with B should equal to C plus D. Am I right? Then if we take A and C, then A multiplied with C should equal to B plus D. A and D, that will call that A multiplied with D should equal to B plus C. And so I'm writing directly that B into C should equal to A plus D. Then B into D should equal to A plus C. And then last one will be C into D should equal to A plus B. Yeah. So if you select A, B, C, D, then these six conditions should follow. If that is following all six conditions, these, then that will be a good array. Okay. So what I am doing here, that I'm selecting numbers from minus 2 to 2. That is all just a observation, like guess. So what I did, that I select numbers from minus 2 to 2. A, B, C, D is randomly selected from this vector. Then what I am doing, that A, B, C, D, uh, all four cannot be 0, because if all four are zeros, then we are going directly to the previous one that we have already considered, and that is not giving us 5, that is giving us 8. Okay. Then there is also one another condition is that all should not be equal. Why? Because we have seen that 2 2 2, this is not satisfying our condition. So for that I also written this. Then what I did that I written all these six conditions. All these six conditions are here. X1 is equal to this and all x6. If all six are true, then what I did that I print the A, B, C, D. Then if I run this code, okay. So if I run this code, then that is giving me four numbers. That is minus one, 2, and minus one. From only here I get that there can be one another type of good array, that is this. So this is a simple technique which you also can use in the contest. Like if you are not getting some random number, so you can use this random. Okay. So what I did get here that there can be an another good array like this. This is only for size 4. Value of n is 2, then 2 into 1, that is 4. This is only for 4. What if I, so first of all, discuss that how it can be a good array. So if we select any two, like minus 1, so multiple of this, that will be 1. Sum of this, that is also 1. You can select any like minus 1 and 2. So multiple of this, that will be minus 2. Sum of these two, that is also minus 2. And if you select, yeah, I think we have selected as much as we can. So this is a good array. Okay. Same as this, if you think for n is equals to that, this is for n is equals to 1. Okay. If you, am I right? No, this is for n is equals to 2. Because value size of this is 2 into n. If you think for n equal to 4, then also you can get that minus 1. What will be the size? That will be 4 into 2. That is 8. So I am writing here that minus 1, 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 and the last one will be 4. I am directly writing from this and this. Okay. If we think for this, you can select any 4. Like if I select these 4, that multiple product of these 4 will be 1, and sum of these 4, that will be minus 3 plus 4, that will be also 1. So that is satisfying. And if you select any like these 4 and okay, select these 4. So what will the multiple product of these 4? That will be minus 4. And what is sum of these 4? That will be also minus 4. So yeah, that is also a good array. So what I got that if n is even, if n is even, then there will be a good array that will be n and minus 1 till 2 into n, size 2 into n. Okay. But if I talk for n, if n is odd, like if n is 3, then size will be 2 into n, that is 6. 1, 2, 3, 4, 5, 6. So if I write 3, minus 1, minus 1, minus 1, minus 1, minus 1, then if I consider it like this subsequence and these two, so for this subsequence, the product of this will be minus 1, okay, and sum of these three will be 1. So that is not equal. Why? Because we are selecting odd numbers of minus 1. Because of that, this is generating a minus here. So for n is equals to odd, we cannot get any another good array. Another good array. So what we got that there can be a good array that we can be 2, 2, 2, 2. After that we got that there can be good array that is consisting only zeros. Okay. After that we got that if n is even, if n is even, then there be a good array that is n minus 1, minus 1, minus 1, and minus 1, and size of these all will be 2 and 2. Okay. Then if n is odd, then there cannot be any another good array. For this we have to consider this 0, 0, 0. Okay. So if we go for code, uh, 1 minute. Okay. So first of all, we are taking input of n, then I'm initializing our initial answer from 1 in, 10 to the power 18. Then answer 1 is 0. Then take an input of this. This is answer 1 plus absolute of array of I. What is this doing? That whatever written array is here. Okay. If we take our good array A 0, then what will be the absolute difference? Like, just think that minus 3 is written here, minus 4 is written here, 2 is written here, 3 is written here, 1 is written here. So what will be the absolute difference of this? That will be 3, that will be 4, that will be 2, 3, 1. So what is that? That is absolute value of these all. So absolute value of these all, I am adding that all in answer and updating our fin with, that is our final answer fin. So updating our fin with the minimum of answer and fin. Okay. So we have considered the good array which we are talking, that was consisting of only zeros. Okay. Then if value of n is even, value of n is 1, then what we can think, that just think that A and B, because value of n is 1, then what will be the size? That will be 2 into 1, that is 2. So just think that first number is A and second number is B. So if we choose any number, um, like what we want, that uh, like just think that we are choosing C and C, then what we want, that A minus C and plus B minus C, this should be as minimum as possible. Okay, so if we select C from A to B, okay, then what will be this, that this will be C minus A and this will be B minus C, and this would be as much as minimum. So just think that this is 0. Okay, so C and C is good. Okay, 1 minute. C minus A, well, we want to find the value of C. Okay, na? So we can think that if like 6 and 9 written there, then if we can select middle value of this, but instead of that, if you select like directly this 6 and 6, then that is giving us, this will be 0 and this is 3. Why? Because if you select any middle value from there, then difference of this and this, that sum will be also equal to B minus A. Okay, so if value of n, let me clean up this code. Okay, so if value of n is 1, then we can update our fin with array of 0 minus array of 1, absolute value of that. Okay, so we have considered that 0 0 0, and if value of n is 1, then we can have considered this part also. Then if value of n is 2, then we also have to consider that part also, that was for 2 2 2. So for that, what I am doing, that initializing goes sum with 0. Okay, initializing goes sum with 0, then for traversing a loop from 0 to 2 power n, then absolute value of array of I, that is array of I with 2, array of I with 2, array of I with 2, absolute value of these all, then sum of that, then update again over fin with that. Then again, if n is even, then also we have to consider that, what is that? That n minus 1, minus 1, minus 1, minus 1. Okay, these all we have considered 0, 0, then 2, 2, then last one is this. This is only valued if n percent 2 is 0. Okay, then what I am doing here, that I am initializing version 2 is 0, then mx 1 is 18. What I am doing here, that any value is written here, we want to take absolute with minus 1. What will be that? Like array of I is written here, so array of I minus minus 1, so that will be plus 1. So I'm updating option 2 with plus 1. So what I'm doing, for every element, I'm taking that with minus 1, adding that sum 2 with minus 1, so that will be array of I plus 1. But for n, what I'm doing, for n I'm doing that, if I replace this particular array of I, instead of minus 1, if I replace that with n, okay, are you getting that? If instead of minus 1, if I replace that with n, what I will do, that I will take mx as minimum as possible, because in final we want to minimize this sum too. So what we will do, instead of this minus 1, if we replace that with n, so absolute array of I minus n minus array of I plus 1. What I am doing here, that we have already added this part here. Okay, what I will do in last, that I will add sum to plus mx. Because of this, this and this will be got cancelled for that particular array of I. Okay, because this is minus, this is plus, so this will be got cancelled, and this for only for this n. 1 minute. Okay, for that particular n, this n will be added and that minus 1 will be got cancelled, because first we added here, then we again subtracting that for particular that array of I, which is giving us as minimum as value possible for this value. So in final I will add that in our sum 2, and then again update our sum 2, and in final we will print our fin. So that is our code for this problem. So what was the main critic point that for this, that anyhow you want to find this part. If you have found this, then you have solved the problem. For that I use this part. So I will also give this code in description. You can check these all things in description. So okay, see you in the next problem. Till then, happy coding. Bye bye.